video, we'll show how to use SimXpert and MD Nastran to perform a basic finite element structural analysis. The workflow between SimXpert and MD Nastran begins with creating your model in SimXpert, then submitting it to Nastran, which will solve for your displacements and compute your stresses and strains, and then you bring your results back into SimXpert for post-processing, where you create your plots and reports. The process we'll follow begins with creating a new SimXpert database in the Structures workspace. Then we'll set our database units, import geometry using File, Import Parasolid. We'll create our solid finite element mesh, and then apply our loads and boundary conditions. Then we'll define our material properties and apply the material properties to the elements of our model. Then we'll perform our linear static analysis using MD Nastran, and access our results, and then create a combined fringe and deformation plot. Let's get started. We begin by selecting the Structures workspace. Now we're ready to define our model units using Tools, Options, and the Units Manager. We select options for length, mass, time, and force units in our English units in this case. Now we're ready to import our parasolid file. We'll select this strut parasolid file and click Open. Once it opens, we can rotate it and view our imported geometry. And we're now ready to create our finite element mesh, which will contain our nodes and elements that we'll analyze. We'll select Solid from the Meshing tab and select our part and enter an element size of 0.5. We'll select Quadratic Elements and click OK. Now that our mesh has been created, we'll create our boundary conditions. On this lower cylindrical surface, we'll constrain the X, Y, and Z translation. Then, we'll apply a total load of 7,080 pounds on this top surface here. We'll enter 7,080 as the scale factor, and then for the direction, we'll enter 0, -1, and 0, so it'll be in the negative Y direction. Next, we're ready to define our material properties. We'll select isotropic and enter a Young's modulus and Poisson ratio to define our material. Then we're ready to create element properties, which will apply this material to our finite elements. We'll select our entire part and the material that we just created and click OK. Now our finite element model is complete, we're ready to create a new Nastran job. We'll give this job a name, in this case strut, and note that it's a linear static analysis, and click OK. It appears in the model browser tree, and we can right-click and select Run. This submits the job to MD Nastran. Once it's complete, we can import our analysis results by selecting Attach Results and strut.xdb. We can then say OK, and we're now ready to view our results. Under the Results tab, we'll select Deformation, and we'll create a deformation plot of our model displacements. Then, to add a fringe plot, we'll select Fringe, our stress tensor, and von Mises, and update our plot. We can close the property editor, rotate our model, and view our stresses in our model. This completes our basic, linear static, finite element analysis. So in this video, you've seen the basic process for using SimXpert, Structures Workspace, and MD Nastran to perform a basic finite element analysis.